Hello, my name is Grant Kimple, and I'm going to be showing how to solve problem 18.17. And in this problem, it asks to propose methods for preparing butanoic acid, which is that molecule right there, from each of the following. And it's going to give a few starting molecules, and we'll go through each one of those and what can be used to get the end compound butanoic acid. So the first one, you're going to start with 1-butanol, and a good method for converting 1-butanol to butanoic acid is by simply oxidizing that primary alcohol on 1-butanol, and this is going to give you the carboxylic acid that we need for getting butanoic acid. And I used chromic acid, and I figured that's a really good suitable oxidizing agent for this reaction. And that one is A. Now B, you're going to start with butanol, and with butanol, this is an aldehyde, and aldehydes can be oxidized to carboxylic acid by many different oxidizing agents. Here I used, on the top of the arrow, I start off with potassium dichromate, and I'm going to add that in the presence of sulfuric acid and water, and that's going to give butanoic acid as well. Now, this next one is you're going to start with 1-butene, and here there's going to be 2 steps on the first part. There's for step 1, you're going to have diborane you're going to add, and you're going to try to you're going to go through the process of hydroboration oxidation, and this is going to be also done on the second step with hydrogen peroxide and hydroxide, and that's going to give you 1-butanol, like we had in our first problem when we started with. And then from here you're going to be able to add chromic acid as just like we did in part A, and result in butanoic acid. So now D is going to be your starting molecule is 1-propanol, and this one, there's a couple of different ways that you can go about this, but all of them you're going to first start by preparing a alkyl halide from the alcohol that you're starting with. So I'll go through one of the ways, and this is what I did. I added PBr3, or you could do HBr, and that's going to give you 1-bromopropane. And from here you could have gone either 2 ways. You could have gone the Grignard reagent method, where you would have added magnesium and diethyl ether, and then had the MgBr on there, the Grignard reagent. But I went with potassium cyanide and dimethyl sulfoxide, and this is going to give me a cyanide right there on the end. So you have a nitrile that we're working with now, and from here a good way to go about getting our final product is hydrolysis of that nitrile. So after we formed it, we go through hydrolysis, and you can do that with just regular water and then HCl and heat, and this is going to give us butanoic acid. So that's problem D. And then E, you're starting with 2-propanol. And 2-propanol, you can start with dehydrating 2-propanol to propene, and this can be followed by the free radical addition of hydrogen bromide, and that's gonna give you 1-bromopropane. And so there we can go back and do what we did in part D right here, and add the potassium cyanide and the dimethyl sulfoxide, and go and get our nitrile, and then go through the hydrolysis step again and get butanoic acid. So the final problem, you're going to have CH3, CH2, CH. Oops, there. Sorry, I was cut off. CH3, CH2, CH, and CO2H, and there's 2 of those, and that's called ethyl malonic acid, actually. And this is a class of substituted malonic acids, and they're gonna undergo thermal decarboxylation pretty readily, just through adding heat. And that's actually just adding heat will yield butanoic acid along with carbon dioxide. So that is question 18.17. Thank you for listening.